Good afternoon, students. This is again Pragnesh Polara from Dr. Subhash Technical Campus, Junagadh. Currently, we are solving the exam paper of May-June 2014 for Advanced Mathematics Group 2. In last session, we have solved question 1 with MCQs and question 2A, and currently we are solving question 2B. In question 2B, we have solved the first question, and now we are moving to the second question. So let us look at the second question of question 2B, that is evaluate limit. Second question is evaluate the limit x root x minus 2 root 2 limit x tends to 2 x root x minus 2 root 2 upon x minus 2, right? So here it is quite easy to evaluate this limit using our formula of limit. First of all, we will write here limit x tends to 2, limit x tends to 2, x raised to x into root x, that is equal to x into x raised to 1/2, that is equal to x raised to 3 by 2 minus this is 2 into root 2, that is equal to 2 raised to 3 by 2 upon x minus 2. Okay, let us again look at here. This one is x root x, that is equal to x raised to 1/2. So x raised to 1 into x raised to 1/2, that is equal to x raised to 3 by 2. In the same way, this is 2 raised to 1 into 2 raised to 1/2, that is equal to 2 raised to 3 by 2 upon x minus 2. And we know that limit x tends to a, x raised to n minus a raised to n upon x minus a, that is equal to n a raised to n minus 1, n minus 1. So this is the formula x raised to n minus a raised to n upon x minus a to the limit x tends to a, that is n a raised to n minus 1. So in this case, we have a is equal to 2. So this one is equal to n, that is equal to 3 by 2, a, that is equal to 2 raised to n minus 1, that is equal to 3 by 2 minus 1. Okay, using this formula. Okay, we are going to use this formula. So this one is equal to n, that is equal to 3 by 2, a raised to n minus 1, that is equal to 3 by 2 minus 1, that is equal to 1/2. So our answer is 3 by 2 into 2 raised to 1/2, that is equal to root 2. So this one is equal to root 2 upon 2. So this one is equal to 3 upon root 2. So that is the answer of our question. This one is equal to 3 by 2 into 2 raised to 1/2, that is equal to root 2. So here root 2 into root 2, here root 2. Root 2 will be cancelled out. So our answer is 3 by root 2. So this is the solution of question 2B second example. Let us move to the third question of 2B, which is here we want to evaluate the limit theta tends to pi by 4. Third one is evaluate limit theta tends to pi by 4 sin theta minus cos theta upon theta minus pi by 4. First of all, here to use the formula of limit for the trigonometry function, first of all we need to take here the format of pi by 4. So as we all know that sin pi by 4, that is equal to 1 upon root 2, and also cos pi by 4, that is equal to 1 upon root 2. So if we multiply and divide by root 2 with the numerator of this expression, so we will get limit theta tends to pi by 4. Here if we multiply with 2 and divide by root 2, then this one is equal to sine theta into 1 upon root 2 minus cos theta into 1 upon root 2. I have multiplied with 1 upon root 2 multiplied by 1 upon root 2 and here root 2, so root 2 will be cancelled out. So this is the same as the above expression upon theta minus pi by 4. So here this one is equal to limit theta tends to pi by 4, this is root 2, this one is sine alpha into cos beta, or I can write here sine theta into cos pi by 4, because cos pi by 4 that is 1 upon root 2 minus cos theta. Here I can write 1 upon root, that is sine pi by 4, okay, upon theta minus pi by 4, right. This one is sine alpha into cos beta minus cos alpha into sine beta, that is the formula of sine alpha minus beta. So using that formula we can write here this one is equal to root 2 will be come out, so limit theta tends to pi by 4, this is sine alpha into cos beta minus cos alpha into sine beta, that is equal to sine alpha minus beta upon this one is theta minus pi by 4, okay. So if we put theta minus pi by 4 is equal to t here, so this one is equal to root 2. If we take theta minus pi by 4 is equal to t, then if theta tends to pi by 4 then t tends to 0, right. So this one is equal to limit t tends to 0 sine t upon t, where theta minus pi by 4 is equal to t we have taken. So this one will be limit t tends to 0 sine t upon t. So as we all know, limit theta tends to 0 sine theta upon theta is equal to 1, so this will be 1, so root 2 into 1, so our answer is root 2, okay. This is the answer of the limit theta tends to pi by 4 sine theta upon theta, and this way we have evaluated this limit, okay. First of all we have used the formula of sine alpha minus beta, that is sine theta minus pi by 4, that is sine theta into cos pi by 4 minus cos theta into sine pi by 4, and then using the formula that is limit theta tends to 0 sine theta upon theta is equal to 1, so we have got this one is equal to root 2, right. So this is the solution of third question of question 2b. Let us move to the question number 3, which is attempt any 2, and this first one is differentiate f of x. Differentiate f of x with respect to x by using the definition of derivative, right. So first of all I want to remind you the definition of derivative, okay. Question number 3a, the definition of derivative, that is f dash x, that is equal to limit h tends to 0 f of x plus h, f of x plus h minus f of x divided by h. Here we have given f of x is equal to cos square x, right. So f of x plus h, that is equal to cos square x plus h, right. So putting these values in this expression, then f dash x is equal to limit h tends to 0 f of x plus h, that is equal to cos square x plus h minus f of x, that is equal to cos square x divided by h. And as we all know, a square minus b square, that is equal to a minus b into a plus b, right. So here I can write this one is equal to limit h tends to 0, this is a square minus b square, that is equal to a minus b, so that is cos x plus h minus cos x and cos x plus h plus cos x, okay, and divide by h, right? So this is a minus b into a plus b, and then we will use c minus c, that is minus 2ss, and c plus c, that is equal to 2cc. So using that two formulas, we can write here, this one is equal to limit h tends to 0, c minus c, that is minus 2ss, that one is equal to minus 2 sine x plus h by 2, that is minus x plus h by 2 into sine h by 2, the c minus c, that is minus 2 ss, because first one, that is x plus h plus x divided by 2, that is 2x plus h divided by 2, that is x plus h by 2, and again x plus h minus x, that is h divided by 2, so that is sine h by 2. In the same way, c plus c, that is 2cc, so this will be multiplied by 2 cos x plus h by 2 in the same way into cos h by 2, that is 2cc, okay, and divide by, that is divide by h, and we will write h is equal to h by 2 into 2, because here we have sine h by 2, so we will use sine theta upon theta, so here h is equal to 2 into h by 2 we will use here. So this one is equal to this 2 and this 2 will be cancelled, so this one is equal to limit h tends to 0, this one is cos x plus h by 2 into cos h by 2, right, into this one into minus 2 sine x plus h by 2, right? So this one, here in this expression we can put directly limit, because this one will not be the infinite or 0, and again into this one is into limit h tends to 0 sine h by 2 upon h by 2. This one will be, if h tends to 0, then h by 2 tends to 0, so sine theta upon theta, that is 1, so this one will be 1. So our answer is limit h tends to 0, our answer will be, this one is equal to limit h tends to 0 cos x plus h by 2 into cos h by 2 into minus 2 sine x plus h by 2, right? This one will be our answer. So if we put h tends to 0, then this one is 0, so that is cos x, okay. In the same way, if we put here 0, then cos 0, that is equal to 1, so this one is 1 into this one is minus 2, and this is, if we put h is equal to, then that will be sin x, so this one is equal to minus 2 sin x into cos x, and minus 2 sin x into cos x, that is minus 2 sin 2x. So differentiation of cos square x, that is f dash x, is equal to minus 2 minus sin 2x. So in this way, using the definition of differentiation, we can find the differentiation of cos square x using the definition limit h tends to 0 f of x plus h minus f of x upon h. So in this way we have find the differentiation of f of x is equal to cos square x, right? So this is the solution of differentiation of cos square x using the definition of differentiation, right? Definition of derivative. So this one is for the first of question 3a. Let us move to the second question, in which we need to find if y is equal to, second one, if y is equal to log in root x square plus s square plus x upon in root x square plus s square minus x, then we need to prove that in root x square plus s square into dy by dx is equal to 2. So first of all, I want to simplify this expression, that log in root x square plus s square plus x upon in root x square plus s square minus x, right? So first of all, this one will be here, if we take this one is equal to x square plus s square plus x upon x square plus s square. Just I want to simplify this expression first. If I multiply with the rationalizing factor, that is in root x square plus s square plus x upon in root x square plus s square plus x, so this one is equal to this one x a minus b into a plus b, that is a square minus b square. So in denominator we will get x square a square, that is this one, that is x square plus a square, because this is in root. If I take the square of this one, then this will be x square plus a square. This s square minus b square, so minus square of x, that is x square, right? And here we will get root x square plus a square plus x into root x square plus s square plus x, that is equal to root x square plus a square plus x whole square, right? And this one will be root x square plus a square plus x whole square divided by a square.